addition theorem, which I haven't taught you.
Trial version.
So I'll take you to one more thing.
Trial version.
Yeah. Odds in favor and odds against.
Trial
Two new
version.
concepts. Heard these terms? Odds in favor.
Trial
There's a
version.
cricket match between India and Pakistan. Odds in favor of India. 3:2.
Trial version.
Odds in favor. It's a ratio.
1:4.
Trial
So
version.
what do you mean by odds in favor and odds against? We frequently use the terms odds in favor, odds against. What does it mean?
Trial version.
Ratio, is it the probability?
It is not a probability, it is a ratio of, you may say ratio of
Trial
probabilities.
version.
You may define it as a ratio of number of successes to number of failures. That is odds in
Trial
favor.
version.
Number of successes to number of failures. That ratio is a odds in favor. So odds in favor of India against odds in favor of India when there's a
Trial
match,
version.
India-Pakistan match. Odds in favor of India, 3:2. That means out of 5, India is likely to
Trial
win
version.
3 and likely to lose 2 matches. Then what is the probability that India wins?
Trial version.
Out of 5 matches, India wins 3. 3 upon 5.
Yes.
Now,
Oh,
if
yes.
I say that odds against India 3:2,
Trial version.
completely different meaning. Odds against means number of failures to number of successes.
Trial
Now, if I
version.
say odds against India 3:2, what are the India's chances of winning?
2/5.
2/5.
Trial version.
Got it now? Then answer this question.
Yes.
A card is drawn from a well-shuffled deck of 52 cards. What are the odds in favor
Trial
of
version.
getting an S? So number of aces is to number of
Trial
non-aces. How many aces are there? I hope
17,
all of you
4 is
know
to-
about the distribution of cards. Girls, do you all know? I'm sure
Trial
boys know
version.
it.
4:48. 1:12.
4:48, that is 1:12. Correct. What are the odds in favor of getting a
Trial
face
version.
card? Now, which are face cards? Which are face cards?
Trial
Jack,
version.
The
Queen?
Jack, King,
Jack,
Queen.
Queen, and King.
Yes. So total how many face cards are there?
12.
12.
Trial version.
12.
And then therefore non-face cards?
40.
40. So what are the odds in favor of getting
Trial version.
getting a face card? 12 is to
12,
40.
5.
That is 3:10. Right? What are the
Trial
odds in
version.
favor of getting a red queen? How many red queens are there?
2. 2:50. 1:25.
And non-red queens, therefore 50. So 2 is
Trial
to 50,
version.
1 is to 25. Are you getting it? What are the odds against getting a spade?
Trial version.
13
Odds
is
against.
to 13.
Yes,
So 3:1.
3:1. 39 is to
Trial
13,
version.
3:1.
Yes, sir.
Clear? Now if I ask you what is the probability of getting a spade?
Trial version.
1:4. 1/4.
1/4, 13/52.
Trial version.
If the odds in favor of an event, not in the question, out of the question, if the odds in favor of an event
Trial version.
A is P is to Q, odds in favor of A, P is to Q, what is the probability of A?
Trial version.
Odds in favor of A, P is to Q,
P by P plus Q.
P by P plus Q. Good. Very good.
Trial
Odds
version.
against A, P is to Q. Odds against A, P is to Q. What is PA?
By P minus Q.
Q by P
Trial
plus Q.
version.
Q by P plus Q. Very good. Okay. Then answer. Number 2. A bag contains 8 red discs
Trial
and
version.
X blue discs. Odds against drawing a blue disc 2:5. What is the value of X? How will you solve it?
Trial version.
Odds against drawing a blue disc 2:5. What is the value of X?
So it should be x
Trial
by
version.
x plus 8 equal to
Be a little louder, not clearly audible.
Trial version.
8 red, X blue, total X, 8 plus X. And odds against blue. If there are 8 red discs and
Trial
X
version.
blue disc, what are the odds against blue?
X is to 8 minus X.
Odds against.
8
Odds
is to
against blue.
8 is to 8
Trial
plus
version.
X.
8 is to
8 minus X.
Trial version.
anyway calculate.
8 is
Should
to
that be
X.
8 is to X?
Yes.
Should this be 8 is to X? So 8 is
Yes.
to X
Trial
is 2 is to 5. 8 upon X equal to 2 upon 5. What is X?
yes sir
8 upon X equal to 2 upon
20.
5.
20.
Trial version.
20. Yes. Okay. What's the probability that a randomly chosen 2-digit positive integer is a multiple of 3? I've already discussed it.
Trial version.
Yeah, that is already done.
So 1 by 3.
Yes, yes.
Yes, a 1 by 3.
That is already discussed. 6 persons sit in a row.
Trial version.
What is the probability that A and B are sitting on adjacent seats? Permutation and
Trial
probability.
version.
Solve and tell me.
Trial version. 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 Trial version.
In how many ways can 6 persons sit in a row?
So 720.
So 6 factorial.
6 factorial,
Trial
720.
version.
And in how many ways A and B are on adjacent seats?
Trial version.
Are you putting them on first and second, second and
Trial
third,
version.
third and fourth this way? Is that your strategy? Then it is wrong. If they are to sit in adjacent rows, adjacent sets,
Trial version.
tie them up. Tie up A and B.
So we can consider them as 1.
As one person. Then how many persons are there?
5.
Trial version.
So in how many ways can these 5 people be
5
arranged?
factorial.
5
5
factorial.
factorial. Now untie them. Now A and B are free.
Trial version.
So in how many ways can they be arranged among themselves? A, B or
2
B, A?
factorial.
2 factorial.
5
So
factorial.
in how
into
many ways
Trial version.
can they be seated so that A and B are on adjacent sets? 5 factorial into 2
2
factorial.
factorial.
That's the numerator.
Trial version.
And total number of outcomes?
6
So
factorial.
240 by,
Divide.
the answer is 240 by 720.
What is the answer then?
1 is to 3, 1
Trial
by 3.
version.
1 by 3 is the answer. It's basically, if you do it this way, that 2 factorial into 5 factorial divided by 6 factorial, then you don't have to do the
Trial
multiplications.
version.
No, sir.
5 factorial goes
2
into 6
factorial by
factorial,
6. 1 by 3.
basically 2 by 6, 1 by 3.
Trial version.
Good going. My mistake is I have given all the answers here
version.
also. And you have to justify. Anshul has 4 different shirts and 4 matching trousers. He picks up a shirt and a trouser randomly.
Trial version.
What's the probability that he is wearing matching pair? See again, dressing up, the same example.
The same color.
Trial version.
Same, not the same color. There are pairs, matching pairs.
Trial version.
If Anshul has 4 different shirts and 4 matching trousers, and there are 4 different combinations.
Trial version.
I mean,
Yes,
4
sir.
pairs are there. Of course, you can break the pair. There are 4 pairs basically.
Yes, sir.
Trial version.
Now he picks up a shirt and a trouser randomly. What's the probability that he is
1
wearing?
by 4.
But 1 by 4 that you
Trial
can see.
version.
But you have to justify why 1 by 4.
4 sets are there. I mean, combination of shirts and trousers.
Trial version.
So
4 shirts, 4
probability-
trousers. He is choosing 1 shirt and 1 trouser.
Trial version.
Total in
Trial
how many
version.
ways this can be done? Selections,
4 factorial.
not 4 factorial. 4 factorial ways of choosing shirts
Trial
only.
version.
He can pick up a shirt in 4 factorial ways.
So 4 factorial and you can pick up a trouser in another 4 factorial. So 4 factorial into 4
Trial
factorial.
version.
That is the denominator.
yes, sir. 4 into 4.
No, I would say
Trial
4 factorial. I think not 4 factorial. He can choose 1 shirt out of 4 shirts, not 4 factorial. He can choose 1 shirt out of 4 in 4C1, that is
Trial
4
version.
ways. He can choose 1 trouser out of 4. 1 trouser out of 4 in 4C1, that is 4
Trial
ways.
version.
So you can choose 1 shirt and 1 trouser in 4C1, that is 4 into 4, 16 ways. Denominator
version.
16. There are 16 ways of choosing 1 shirt and 1 trouser.
Yes, sir. Yes.
Now, what are the
Trial version.
number of favorable outcomes? That it is, he
The
is
number of
choosing.
matching pairs are 4. So he'll choose 4 by
Yes, sir.
16. That's
4 by
1 by
16.
4.
1
Yes.
by 4.
Trial
One
version.
matching pair can be chosen in 4C1 ways. Because there are 4 matching pairs, he can choose 1 matching pair in 4C1 ways. So numerator 4C1, denominator
Trial
4C1
version.
into 4C1. Answer is 1/4. These are elementary actually.
Trial
2 dice are
version.
thrown. What are the odds in favor of getting a sum of 5? First answer this. Odds in favor of getting
Trial version.
a sum 5.
Trial version.
Total number of outcomes. Write down. Total number of
Trial
outcomes.
version.
Yes, sir. Sir, 1 is to 6 because 6 is to 36. I mean, 1, 5, 2, 4,
Trial
3,
version.
3,
The total number
Then,
of outcomes 6 into 6, 36.
36. And
Out of which, in how many ways
From
can you
5.
get a total 5?
Trial version.
2, 3, 3, 2.
Trial version.
4 ways.
4 ways.
4 ways. So
So
4
4 is
are
to
in
32.
favor.
Trial
4 is to
version.
32. Correct.
1 is to
1 is to 8. And what are the odds against getting the sum 6?
Trial version.
In how many ways you can get a sum 6? 1, 5, 5, 1. 2, 4, 4, 2.
Trial version.
3, 3. 7 ways.
Yes, sir.
I'm sorry, 5 ways.
So 5 ways, sir.
5
5
ways.
is to 31 is
So
to
in
5.
how many ways?
Again,
Trial
In how many
version.
ways he cannot get sum 6?
31 is to 5.
31 ways. So number of failures to number of successes. 31 is
Trial
to 5.
version.
That is the answer. Conceptual, basically. In a single throw
Trial
of
version.
3 dice, find the probability of getting the same number on the 3 dice.
Trial version.
When you throw 3 dice, total number of outcomes
216.
Yes,
6
sir.
into 6 into
Trial
6, 6
version.
cube, 216. Okay. Number of favorable outcomes. Getting the same number on the 3 dice. In how many
Trial
ways can
version.
this be done?
6 ways.
6 ways, all 1. 1, 1, 1. 2, 2,
2, 2,
2.
2, 3, 3, 3.
Yes, so the event A
Trial
in this
version.
case, A is equal to 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. Number of outcomes, number
Trial
of favorable
version.
outcomes 6. Therefore, the answer is 6
1 is to
upon
36. 1 by
6
36.
1 by 36.
Trial version.
2 cards are drawn simultaneously from a pack of 52 cards. Find the probability of getting both red cards.
Trial version.
Two cards are drawn,
Trial version.
getting both red cards. First, the denominator, total number of outcomes. In how many ways 2
Trial
cards can be
version.
drawn?
So 52 into 52 ways.
Once again,
52 into
Trial
52 ways.
52 into 52.
Yes, sir.
Trial version.
You are drawing 2 cards simultaneously. How can it be 52 into 52?
Trial version.
2 cards can be drawn out of 52 cards in 52 C2 ways combination.
Trial version.
So 52 into 51.
Yes, sir. 52 into 51.
52 into 51.
Trial version.
No.
Trial version.
I may say so. In that case, the
Trial
numerator,
version.
both red.
Trial version.
Sir, but both the cards can be same. So how can it be
Trial
52 into
version.
51?
Both are.
Both the cards can be same. I mean, can
How?
be 51.
How can be same?
Trial version.
You are drawing 2 cards simultaneously.
When we draw one card, it's already
Oh,
becoming 51, no?
Yes.
Yes, sir. Just
Trial version.
And in how many ways you can draw 2 red cards? There are 26 red cards.
Trial version.
25.
So 26 into 25.
Yes. So the probability?
Trial version.
25 by 102.
25 by 102.
Trial version.
You may also do it this way, that 2 cards can be drawn 52 ways and it can
Trial version.
into C C2 divided by 52C2. Part 2. Getting two red
Trial
pictures.
version.
Very similar actually. Two red pictures. Two red picture cards. Now, red
Trial
picture
version.
cards are Jack, Queen, King. Red picture, how many? In every
Six.
suit there are, yes, 6. In every suit there are
Trial
3.
version.
So red means heart and diamond.
Trial version.
So 6. Getting two red pictures, 62 divided by 52C2.
Trial version.
This one is interesting.
Trial
I should
version.
not show you the answer.
Trial version.
Four married couples have gathered in a room. Two
Trial
persons are
version.
selected at random. Find the probability that the selected persons are a husband and his wife. Part 1.
Trial version.
There are four married couples. Two persons are selected. The probability that they are
Trial version.
his wife and his wife, one couple.
Trial version.
Do you find a similarity with the sum that we have already solved?
Trial version. Trial version. Trial version.
Anyway, solve it your way.
Trial version.
Total number of selections without any restriction. Two persons are to be selected.
Trial
In how many
version.
ways can two persons be selected? There are 8.
So
There are
8 into
4
7
married
ways.
couples. 8C2.
Trial version.
56 ways.
Yes, sir. 8 into 7 ways.
Trial version.
Two persons can be selected out of 8 in 8C2 ways.
Trial version.
And the husband and his wife can be selected in how many ways?
4C2 ways.
Trial version.
4C2
4C1.
ways. 4C1.
4C1. Because there are four
4C1.
couples actually, and we are selecting one couple. So 4C1. Therefore, the answer is
Trial
4C1
version.
divided by 8C2. Work it out. 4C1 divided by 8C2.
1 by 12.
Trial version.
1 by 12. Or 1 by
1 by 12.
Trial version.
One by 12.
1 by 7. 1 is 1 by 7.
Trial version.
1 by 7. Yes. Okay. Our first answer is 1 by 7. Second answer.
Trial
A
version.
gentleman and a lady, but not a couple.
Trial version. Trial version. Trial version.
So 2 by 7.
Trial version.
2 by 7. Justify.
So 4C1 C1 by 8C2.
4C1,
Trial
4C1. But the condition is, but not a couple. If you go for 4C1 into 4C1, there's a possibility that
Trial
you are
version.
choosing a couple.
Trial version. Trial version. Trial version. Trial version. Trial version.
Anyway, denominator is certainly 8C2 because there are 8 persons altogether. 2 persons can be selected out of
Trial
8 in
version.
8C2 ways, 28 ways. Numerator. We have to select one gentleman. How many ways? There are 4
Trial
gentlemen.
version.
One gentleman can be selected in 4C1 ways. Gentleman selected. Now a lady has to be selected who is
Trial
not
version.
his wife.
So 3. Like, there are
3C1.
three.
So 4C1 into 3C1 is the numerator.
Trial version.
One gentleman and a lady who is not his wife can be selected in
Yes, sir.
4C1 into 3C1 12 ways.
Trial
So the
version.
answer is 12 divided by 28. 3 by 7. Okay.
Trial version. Trial version.
A number of 4 different digits is formed by using 1, 2, 3, 4, 5, 6, 7.
Trial version.
Find the probability that it is divisible by 5. A number of 4 different digits formed by using
Trial
these.
version.
There are 7 digits altogether. We are
Trial
finding the
version.
probability that it is divisible by 5. 4 different digits.
Trial
So
version.
1 by 4.
Justify.
Sir, total number of possibilities are 7 into 6 into 5 into 4.
Trial version.
Okay.
And divisible by 5, 7 into 6 into 5 into 1, because the unit digit can
Trial
only be
version.
1. It can only be 5.
Now repeat the numerator once again.
Numerator 7 into 6 into 5 into 1.
Trial version.
Why 7 into 6? Why 7?
Trial version.
It has to be divisible by 5. So the
Trial
units
version.
place is already reserved.
6 into 5
Units
into
digit
4
must be 5.
into 1.
Hmm?
6 into 5
Trial
into 4
version.
into 1.
6 into 5 into 4 only.
Yes, sir.
6 into 5 into 4 divided by
7 into 6
Trial
into
7
version.
into 6 into 5 into
4.
4. Answer.
Trial
1 by
version.
7.
1 by 7. In fact, I would go for this. A 4-digit arrangement can be formed using 7
version.
different digits in 7p4 ways. Use this. It will be easier for you. 7p4. So the denominator,
Trial version.
number of digits, there are 7 different digits. A 4-digit arrangement can be formed
Trial
in
version.
7p4 ways. Since the number is divisible by 5,
Trial
the
version.
units digit must be 5. The remaining 3 places can be occupied by
Trial version.
3 digits amongst 1, 2, 3, 4, 6, 7 in 6p3 ways.
Trial version.
6p3. Number of places to be filled up 3. Number of digits available 6. 6p3. And
Trial
therefore
version.
the required probability is 6p3 divided by 7p4. 6p3 divided by
Trial
7p4.
version. Trial version.
Out of 9 outstanding students in a college,
Trial version.
there are 4 boys and 5 girls. Boys are outnumbered. 4 boys,
Trial version.
5 girls. A team of 4 students to be selected for a quiz program. Team of 4.
Trial
Find the
version.
probability that 2 are boys and 2 are girls.
Trial version.
So it should be 4c2
Trial
into
version.
5c3 by 9c4. 4c2 into
4c2 into 5c3.
5c2 by
Yes.
9c4.
Trial
Yes,
version.
very good. Very simple. When you find out the denominator, when you look at the denominator, don't look at the conditions. Basically, you are selecting
Trial version.
4 students. Out of 4 plus 5, 9 students. 4 students can be selected out of 9 in
Trial version.
9c4. No, why? When do we choose C and when P? What is the rule?
Trial version.
We know that C for combination. If you use the letter C
Number
for
of choices.
choosing.
Trial
So
version.
9 choose 4, 9c4, that way. It's a case of 9 choose 4. So 9c4.
Trial version.
And the numerator, 2 boys can be selected out of 4 in 4c2 ways. 2 girls can be selected out of 5 girls in 5c2 ways.
Trial
So
version.
2 boys and 2 girls can be selected in 4c2 into 5c2 ways. So first we write
Trial version.
4 students can be selected out of 4 plus 5 equal to 9 students
Trial version.
in 9c4 ways. Two
Trial
boys
version.
can be selected out of 4 in 4c2 ways.
Trial version.
2 girls can be selected out of 5 in 5c2 ways.
Trial version.
Therefore, 2 boys and 2 girls can be selected in 4c2
Trial version.
into 5c2 ways.
Trial version.
Therefore, the probability that 2 are boys and 2 are girls
Trial version.
is equal to 4c2 into 5c2 divided by 9c4.
Trial version.
Answer is 10 upon 21. Check.
Trial version.
Sir, we use P for arrangement, right?
Yes.
Trial version.
When the order matters.
Trial version.
Next, the letters of the word equation are arranged in a row.
Trial version.
Find the probability that all the vowels are together. First question. All vowels are together.
Trial version.
So this is one of those words in which all 5 vowels are there.
Trial version. Trial version.
All 5 vowels are together.
Trial version.
When things are
4
together,
factorial into 5 factorial by 8 factorial.
Trial version.
So
4
5
factorial.
factorial into factorial by 8 factorial.
Trial version.
Because the 5 vowels can be taken as 1.
Yes.
So there are 3 vowels which can be taken as one.
There are 3 vowels.
There are 8 letters.
Trial version.
Huh?
So,
So
Number of vowels?
So there are
8
5
minus 3
vowels.
is 5.
5 vowels and 3
5 vowels.
consonants.
Yes, sir. So we can take
Trial
5 vowels
version.
as 1 and 3 consonants, so 4. So we can arrange themselves as 4 factorial, and then the vowels can be arranged in 5 factorial ways.
Correct.
So 4 factorial into 5 factorial by
Trial
total
version.
number of arrangements, it is 8 factorial.
Very good. Is that clear to you? Because the vowels are taken together, there are 5 vowels.
Trial version.
So taking 5 vowels together as one single unit. Number of units 1 plus 3. 3 consonants. 1 plus 3, 4.
Trial version.
These 4 units can be arranged in 4 factorial ways, and then the 5 vowels can be arranged among themselves in 5
Trial
factorial
version.
ways. Therefore, the number of arrangements in which all the 5 vowels are together is 4 factorial into 5 factorial. That's the numerator.
Trial version.
Number of arrangements in which all 5 vowels are together is equal to
Trial
4
version.
factorial into 5 factorial. No need to simplify this. Let it be like this. 4 factorial into 5 factorial. The letters
Trial
of the
version.
8 letters of the word, the 8 letters of the word can be arranged in 8 factorial ways.
Trial version.
Again, let it be 8 factorial. No need to find the value.
Trial version.
Therefore, the probability that all the vowels are together is equal to, now divide, is equal to 4 factorial into 5 factorial divided by 8
Trial
factorial.
version.
Now you make divide 8 factorial by 5 factorial straight. And what do you get? 8 into 7 into 6.
Trial version.
And now you can simplify, do the cancellations. What's the answer?
Trial version.
Get the answer. What is it?
Trial version.
So 1 by 84. No, sir.
Are you all
1.
getting?
Trial version.
Are you all getting the same? Are you getting 1 upon
1
84?
by 14.
Trial version.
First answer 1 upon
Trial
14.
version.
Now the second one. Now if you have any difficulty in number 1,
Trial version.
I'll repeat. It is 4 factorial into 5 factorial divided by 8 factorial. Cancel
Trial
8
version.
factorial by 5 factorial and you get 8 into 7 into 6. So now it is 4 into 3 into 2 divided by 8 into 7 into 6.
Trial
Do the
version.
simplification. You get 1 upon 14. Second question.
Trial version.
Find the probability that I'm sorry. The probability that the arrangement starts with a vowel and ends with a consonant. So the
Trial
first place
version.
and last place are reserved. First place reserved for a vowel, last place reserved for a consonant. And then once these
Trial
two places
version.
are filled up, you're free to fill up the remaining places. Total
Trial
number of
version.
arrangements, as you know, it is 8 factorial. Denominator is going to be 8 factorial. Numerator, number of favorable
Trial
outcomes.
version.
That is, the word is beginning with a vowel and ending with a consonant. So in how many ways the first
Trial
place can be
version.
filled up? In how many ways can the first place be filled up? There are 5
Trial
vowels.
version.
We can fill up the first place in 5 P1 ways. That is 5 ways. The last place
Trial
can be
version.
filled up with a consonant. There are 3 consonants. So 3 P1 ways. 3 ways.
Trial version.
The remaining 6 places can be filled up with the remaining 6
Trial
digits.
version.
In how many ways? 6 factorial ways. So the answer 5P1
Trial version.
into 3P1 into 6 factorial divided by 8 factorial.
Trial version.
So can I explain this again, the last part?
Trial version.
The first place can be filled up with a vowel in 5P1 ways.
Trial version.
The first place can be filled up with a vowel in 5P1 ways.
Trial version.
The last place of the word can be filled up
Trial version.
with a consonant
3P1. Yes.
in 3P1 equal to 3 ways.
Trial version.
The remaining 6 places of the word can then be filled up
Trial version.
in 6 factorial ways.
Trial version.
Therefore, the probability that the arrangement starts with a vowel
Trial
and
version.
ends with a consonant
15 by 56.
is equal to 5 into 3 into 6 factorial
Trial
divided
version.
by 8 factorial. 6 factorial goes into 8 factorial and it gets 8 into 7. So basically it is 5 into 3 divided by
Trial version.
8 into 7.
Trial
15
version.
by 56. Okay.
Trial version.
Out of 8 points in a plane, it's a plane.
Trial version.
Out of 8 points in a plane, 5 are collinear. Find the probability that 3
Trial
points
version.
selected at random will form a triangle.
Trial version. Trial version. Trial version. Trial version.
5 are collinear, that means 5 points are on the same straight line.
Trial version.
Remaining 3 are scattered. 3 points
Trial
are
version.
selected. What's the probability that they form a triangle?
Trial version. Trial version. Trial version. Trial version.
When there are too many possibilities, just
Trial
think of the
version.
complementary event.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial version. Trial version.
Suppose A is the event that the 3 points form a triangle. Then A complement is the event that they don't form a triangle.
Trial version.
In which cases 3 points will not form a triangle? Can you tell me?
Points which are collinear.
When all the 3 points are
Trial version.
collinear.
Yes.
Can you find out the probability of A's complement?
Trial
What's the
version.
denominator? To find
Sir.
out PA's complement, what's the
It's like
denominator?
5C3 by 8C3.
Exactly, 5C3 by 8C3. Then what is
Trial
PA?
version.
If you know PA's
1 minus
complement,
5C3 by 8C3.
so simple, so easy. I told you, I
Trial
gave you a
version.
hint. Think of the complementary. So what is the value?
Trial
1
version.
minus 5C3 upon 8C3. A is the event that the 3 points form a triangle. A bar or A prime is equal to the event
Trial
that
version.
they do not form a triangle. PA complement is equal to 5C3 upon 8C3. Simplify this. What is the
Trial
value?
version.
5C3 is 5 into 4 by 2 factorial, that is 10. 8C3 divide.
Trial version.
So what is 5C3 upon 8C3?
Trial version.
What's the answer?
Trial version.
— 23 by 28.
Yes.
Trial version.
1 minus 25 by 28. 1 minus 5 by 28.
1 minus 5 by 28.
Trial version.
Okay, now we'll learn these addition theorems, because if I'm going on to the next part of it,
Trial version.
so very quickly I'll go through the addition theorem of probability. I told you that I would discuss later.
Trial version.
Addition rule of probability says that if A and B are any two events in a sample space,
Trial version.
then probability of A union B, note it down.
Trial version.
A intersection B.
So like in sets,
Yes.
Venn
In
diagrams.
sets you learned N, the cardinal number. N
Trial
A union
version.
B equal to NA
Yes, sir.
plus NB minus N A intersection B.
Yes, sir.
Here change N to P. Similarly, for 3 sets,
Trial
for
version.
3 events, not sets, for 3 events ABC, P A union B union C is equal to, see there's a pattern.
Yes, sir, we did this
Trial
in sets.
version.
We substituted
Yes,
the value
yes.
of substitute the P as N.
PA plus PB plus PC, probability of the events taken one at a time.
Trial
Minus
version.
PAB minus PBC minus PCA. That is minus probability of intersection of two events. Then again plus
Trial version.
probability of intersection of three events. Then again minus probability of intersection of four events, and so on. It goes on and on, provided there are n number of events.
Trial version.
But for ISC, it is restricted to 3 events maximum. You will never get more than 3 events. So this is the maximum limit. PA union
Trial
B
version.
union C. Now what happens if the two events A and B are mutually exclusive?
Trial version.
Mutually exclusive means they cannot occur simultaneously. So A and B cannot occur simultaneously. Head and tail cannot occur simultaneously.
Trial version.
Pass and fail cannot occur simultaneously. So PA intersection B is 0.
Trial version.
For if A and B are mutually exclusive, remember, PA intersection B is equal to 0. So you may write down a small
Trial
note.
version.
If A and B are mutually exclusive, then PA intersection B is equal to 0. Just remember this.
Trial version.
In that case, PA union B is equal to PA plus PB. Because PA intersection B is 0.
Trial version.
Similarly, PA union B union C will be just PA plus PB plus PC,
Trial
because
version.
they are pairwise mutually exclusive. Right, only these two rules for class 11. There are
Trial
many
version.
other rules, but only these two for class 11. If I take few examples here,
Trial version.
big stories, very big stories.
Trial version.
Can't give anything simple.
Trial version.
Anyway, I'll take these sums.
Trial version. Trial version. Trial version.
E union F. And number 2, P not E and not F.
Trial
We'll come to
version.
this later. So the solution.
Trial version. Trial version. Trial version.
So P not E and not F is 1 minus
Trial
P E or
version.
F, right?
Why?
So it's a complement. That's all.
Trial version.
There's a rule, there's a law. Can you tell me which rule?
Oh, that
Trial version.
A complement intersection B complement is union B equal complement.
Which rule is that? There's a name.
And Demarcan.
Yes, Demarcan's law.
Trial
Good.
version.
So I'll solve one by one.
Trial version. Trial version. version. Trial 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 version.
PE union F. We
Trial
don't
version.
know.
Trial version. Trial version. Trial version.
Minus PE intersection F, that is 1/8.
Trial version.
Is equal to 5/8.
Trial version. Trial
This is
version.
part 1.
Trial version. 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 Trial version.
This is De Morgan's law. PE complement intersection
Trial
F complement is equal to P E union F whole complement.
Trial version. 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 Trial version.
Okay.
Trial version.
How do you solve this? In a hostel, 60% of the students read Hindi newspaper, 40% read English newspaper, and 20%
Trial
read both
version.
Hindi and English newspaper. A student is selected at random. Find the probability that she reads neither Hindi nor English newspapers.
Trial version. Trial version. Trial version.
Define the events.
Trial version. 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 Trial version.
So what is given is PE.
Trial version.
English newspaper, 40%. No, I'm sorry, 60%. Hindi, 40% English. Yes, 40%.
Trial version.
0.4.
Trial version.
PH, 60%. 0.6. What else?
Trial version.
20% read both Hindi and English newspapers. Both Hindi and English.
Trial version.
Hindi and English.
Trial version.
20%. These are given.
So 1/5.
Yes.
Trial version.
Student is selected at random. Find the probability that she reads neither Hindi nor English. Required probability.
Trial version.
So the union is 0.6 plus
Trial
0.4
version.
minus 0.2,
Hmm.
and the ones that treat neither of them is 1 minus 0.8.
Hmm.
So 0.2
Trial version.
by total 1.
Yes.
Trial version. Trial version. Trial version. Trial version.
Neither Hindi. So H complement. Write this way. H complement.
Trial version.
Not English. So and not English. And not English.
Trial version. Trial version.
Morgan's law.
Trial version. Trial version. Trial version. Trial version.
Actually, two steps together.
Trial version. 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 Trial version.
Now put the values. 0.4
Trial version.
pH. 0.6. 0.
Trial
Oh.
version.
Minus 0.2.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial
I think we can
version.
take one more.
Trial version. 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 Trial version.
Solve. Card is drawn at random from a pack of 52 cards. Find the probability that the card is either a spade
Trial
or an
version.
S or both. How do you proceed?
Trial version.
Should you proceed analytically, like thinking of the spade or ace or both, all the possibilities,
Trial version.
counting the spades, counting the aces, counting spade and ace? Should you do that
Trial
or
version.
use addition rule, addition theorem of probability?
Addition theorem.
So how do you define the events?
Trial version.
Define the events.
Trial version.
Suppose A
Trial
is the
version.
event that the card is a spade.
Trial version.
B is the event that the card is an S.
Trial version. Trial version. Trial version. Trial version. Trial version.
Required probability. E. A union B.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial
Values.
version.
PA.
Trial version.
Probability that the card is a spade. 13/52.
Yes, sir.
Trial version.
That's PB. The card is an S. There
Trial
are
version.
4
4
S's
upon
plus 4/52.
Is it 15 by 52?
Answer.
Trial version.
Yes, sir.
I don't know. Check.
So
PA intersection B.
2 upon 52.
Ace of spade.
Trial version.
Y2. Y2.
1 upon 52.
How many aces of spade are
Trial
there?
version.
Only one.
1.
One ace of spade.
Trial version.
Right.
4 upon 13.
Trial version. Trial version.
Yes.
Trial version.
So there are some more good questions, which I may take
Trial
next
version.
class. Meanwhile, you solve all the remaining sums of M.L. Agarwal and Malhotra Gupta or R.D. Sharma or any other book. Solve all.
Trial version.
And tell me your difficulties in the next class.
Okay,
So
sir.
next class will be completing probability and we will
Trial
start
version.
a new chapter. Which one?
So you can start
Trial
statistics.
version.
So binomial theorem
Statistics or binomial theorem. Any other chapter?
or induction.
Induction.
Trial version.
Statistics can be done because you may need, all of you may need statistics. But if you say that the statistics is
version.
easy, you may handle it yourself.
For the later chapters, like you can do index numbers.
Index number
Trial
section,
version.
that's too easy. One of the easiest. Too easy. I want to take this at the end. When do you
So
have
we
the
can do
exam?
induction
Trial
or
version.
binomial theorem.
Yes, that is important. Induction and binomial theorem, these two are important. By the way, when do you have your next exam? I mean, any
So in our school they have not started statistics yet.
23rd, we are having our
23rd November.
Trial version.
Yes, sir.
And which chapter is not done for that syllabus?
So I don't think so. I think we have done both the chapters. We have sequences and series,
Trial
and
version.
we have. So 1 minute, I'll tell you.
Trial version.
I would love to take binomial theorem.
So we have induction and statistics, induction and
Trial
sequence and
version.
series.
So I want to take induction next.
Okay, sir.
Is it okay? I'll take induction
Yes.
Trial version.
so that I can start binomial theorem next. Induction, binomial theorem, then we can move on to statistics. Because by any
Trial version.
chance that if statistics not done for the examination, you can manage yourself. But these are more important than statistics.
Trial version.
Of course, we'll do statistics.
So
Not
binomial
that we'll-
theorem has many applications in other
Yes,
topics
yes,
also. Yes,
yes.
sir.
That is the reason.
Like in physics also, we
Hmm,
have
hmm.
the application of
Trial
binomial theorem.
version.
And then what happens, they are reducing the chapter so much, the syllabus. Many important things are knocked off.
Trial
Binomial
version.
theorem, in fact, the important features of binomial theorem, important properties are removed from the syllabus. Like approximation,
Trial
in
version.
physics you need approximation. That 1
Yes,
plus
sir,
x whole
that
to the power
power
n
we
equal to...
consider it as coefficient.
Okay. Yes.
1 plus x to the power
Trial
n, we
version.
consider it as 1 plus nx.
Yes. Why is that so? That you don't know.
So there is a proof, I think.
There is, of course, there's
Trial
a proof.
version.
When x is very
But-
small, then x square and higher powers of x are neglected.
Yes,
That is why
it's
we keep
negligible.
the first two terms only.
Yes,
In
sir.
Trial
fact,
version.
1 plus x whole to the power n will be an infinite series in which we keep only the first two. Not
Yes.
not whole
Trial
to the power
version.
n. Yes. Okay, so if you have some other difficulties from the other books, we'll discuss those
Trial
sums and
version.
start induction then, next class. Okay, then we'll meet next week. Good night, everyone.
Trial
night,
version.
Thank you, sir.
Trial version.